This is lesson 12 on your packet. This is module 1B. So today what we're going to do, we're going to write some angle proofs that it has some constructions in them. So first, let's try to see the opening exercise. So it says in each figure determine the measure of the unknown angle. In this case is angle 1. So notice it's the big angle right here. From previous problems, we've used this line called the auxiliary line that goes through the angle 1. This does not mean that it's bisecting, it's just going through. The whole idea with this is to help us locate some alternate interior angles. So I'm just going to highlight some alternate interior angles. Some of your teachers refer to this as the Z shape. So if we are able to find the Z, or an inverted version of a Z, we should be able to find alternate interior angles. So let's see. So we can see the 41. It's actually, in fact, somewhere over here. So 41 should be there. You repeat this step and you're going to see that there is a inverted Z. So 35 right here. It's actually 35 right there. Now I could say that angle 1 is the sum of 41 plus 35. In this case, it's just 76 degrees. Okay, auxiliary lines and then alternate interior angles. Very, very similar. We're going to use the same strategy. We're going to draw some we're going to draw some auxiliary lines. So first I have to extend my lines, my parallel lines. Notice that those two with the two arrowheads in the middle of the lines mean that those two are parallel. So the blue ones are parallel to each other and the red ones are parallel to each other. Notice that there is actually a point of intersection right here. So we need to determine what angle 2 is equals to. That's the question. So let's see. Once again, let's bring some colors or highlighters that might help you and see if we can determine alternate interior angles. Again, my two red ones are parallel to each other and the transversal should be the blue line. So we can say that 34 is in fact right here. If we do the same thing for the other two, I could say the blue line right here with the red one and the blue one right here, two parallel lines, alternate interior angles once again. So I could say that angle 2 is in fact where angle 4 should be. So in this case, I could say that 34 and angle 2 have to be the same angle. Angle 2 is equals to 44 degrees. 34 degrees. Okay, so let's move on to the next page. You're going to notice that actually I did my graph. I extended my lines. The idea with this is that I want to make sure I notice this point of intersection right there. And let's call it maybe M, just as the point of intersection. Okay, so notice what the proof says. Take a minute and write your givens the way I did. All I have is AB parallel to DE. So those two segments are parallel to each other. So the red ones in this case, DE. And the blue ones, in my case, BC is parallel to EF. That's the only information I have. So now let's begin. So look back to the previous page and notice that similar steps are going to happen. So I'm going to call this maybe angle 1. And we're going to call this angle 2. So instead of proving that angle 1 and angle E are the same, I could say that angle 1 and angle 2 are the same. That's the goal, the ultimate goal. I need to prove that angle 1 and angle 2 are the same. Okay, so let's see. If we follow the same steps that we did previously, I could see there were a red one, a blue one, and another red one. The red ones are parallel, so I could say that alternate interior angles once again. So angle 1 should be right here. Let's call that angle 3. So let's write our step. So angle 1 should be congruent to angle 3. The reasoning is parallel lines cut by a transversal line. Form alternate interior angles. And in this case, we know that alternate interior angles are in fact congruent. So that's actually a plus. So let's do it again, just like the previous exercise. We notice another Z right here, the two blue lines, and the red one in the middle is the transversal one. So I could say, in fact, that these two, angle 3 and angle 2, should be the same. So my third step should be the same. I'm not going to make a third step. I'm just going to say that angle 3, is in fact, apologize for that, is congruent to angle 2. Okay, I don't have to rewrite the statement, the reason, because I already have the statements. I have my two statements, it's the same reason. So my last step should be in this case, if you notice that angle 1 is equals to angle 3, so is angle 2 is equals to angle 3. So I could say that actually angle 1 should be the same as angle 2. Just notice that your previous step and your reason should be by substitution. You're substituting it in. Substitution. All right, so that's it for your proof. Let's move on to the next page. In the first part, it says, in the identical diagrams pictured below, there are at least two possibilities for auxiliary lines. Can you find them? I drew them for us. Notice that I have one that goes exactly through angle Z, and another one that goes that is just extending that line that it's making angle C and making this tiny little triangle. So let's do the first proof. We're going to do the left one under that graph, and we're going to say, well, I have my givens. My givens are exactly the same for both graphs. So let's start with the first part. So we're going to say statement. The second statement should be that angle X in this case is equals to angle 1. And we're going to label angle 1 right here. So I'm saying that angle X and angle 1 are exactly the same angles. The reasoning behind that is that they are corresponding angles. Corresponding angles. They are congruent. I'm gonna make my little equals with the squiggly. Okay, so let's repeat that again for y and angle 2. So notice that now angle y and angle 2, so I'm going to say that angle y and angle 2 right here are not actually corresponded, they are vertical. So I could say that angle 2, angle y and angle 2. Angle y and angle 2 are congruent due to that they are vertical angles. Vertical angles are congruent. Right, so now notice that angle 2 is also located up here. Right here, I'm gonna say. So maybe let's call that angle 3. Okay, so we can say that angle 2 and angle 3 are in fact congruent by angle 2 and angle 3 are in fact congruent. Let me move this down a little bit. The reason is by parallel lines cut by a transversal line. Form alternate interior angles. Alright, so now last but not least, let's try to substitute some of these things. So my fifth step should be, notice that I'm trying to prove that angle x plus angle y is equals to z. So let's see. If I add angle 3, let's see, angle 3, angle 1 and angle 3 is in fact equals to angle z. Right? So that is the additive property. Property of angles, you could say. And the last part should be step 6. It should be that angle x plus angle y is equals to angle z. And the reason behind that is that if you notice angle 1 up here, it's now called angle x, and so is for angle 3 right here. It's called angle 2, but in this case, angle 2 is angle y, so now we can say that it's by substitution. My next proof it's gonna have a few other steps. Now remember we extended that vertical that line to make this little triangle. So we're gonna label some angles 1, 2, and 3. So I'm gonna say this is gonna be angle 1, this is going to be angle 2, this is going to be angle 3. So we are going to do the following. So let's label this angle 1, angle 3, and angle 2. And you'll see why I'm going to do this. Actually, let's start with angle 1 only. So as you can see, angle 1, there is some relation between angle 1 and angle x. And yes, it are corresponding angles. So angle 1 and angle x are actually corresponding angles. So I could say 2, angle 1 and angle x are congruent. The reason is corresponding angles are congruent. Corresponding angles are congruent. Notice for angle y, there has to be another angle right across from it, so it helps me put my triangle together. So I could say that angle y and angle 2 are congruent. And yes, vertical lines. Angle 2 and angle y are congruent by vertical lines. They are congruent. Vertical angles are congruent. Number 4 would be that the sum of angle 1 and 2 are equals to 1/8 angle z. So we can say angle 1 plus angle 2 is equals to angle z. And the reason is the exterior angle theorem. Alright, so now that I know that those two angles, when you add them, gives you the exterior angle, the opposite exterior angle. Now all I have to do is just notice that angle 1 and angle 2 could be called differently. So let's put that in blue. Angle 1 is actually called angle x as well, so angle x. So is angle 2 could be called angle y. So angle x and angle y in fact are equals to angle z. And the reason is substitution. Now remember, you could have less steps. You may notice something quicker. So just make sure you're using the proper vocabulary. So let's move on to the next page. Um, so notice that I point at these two little bars next to each other. That just means that AB is parallel to CD. Read the problem over and over again to make sure you notice what your givens are and what is your ultimate goal. So, okay, so let's see, AB and CD are parallel to each other, BC is parallel to DE, so those are my givens. So let's try to extend some of these lines first, so it's a little, there's a little more of a picture. So I'm going to try to extend this one right here, right there. So I'm going to extend this one right here as well. The goal again is angle B and angle D have to be congruent. So let's see, I'm going to call this right here angle B. I'm going to call it angle B. And this one right here angle D. So we're going to call this one right here angle D. Okay, so now I didn't extend the other two lines because I think we should be able to just notice some shapes. Yes, the Z shape, it should be there. If you notice, there's one right there. I have two parallel lines, the blue ones, the extended ones, those are parallel to each other. So I could say that angle B is actually also located over here. And that would be, let's call that angle 1. So my next step should be that angle B is congruent to angle 1. And the reason is parallel lines cut by a transversal line. Transversal line form alternate interior angles. Okay. Now, if you turn your paper around, you may notice one more pair of actually another Z shape. Let's see if we can draw it, just not extending the lines too much. So let's see, let's do it in red. And let's do this one right here and this one right here. Okay. So we can say that angle right here, let's extend this. Oops. Okay, so we can say that actually angle 1 and angle, I'm sorry, angle 2 and angle D. So let's call this one right here, angle 2. Notice the Z shape right away. I'll do it in purple. Right here. Notice that my blue lines are parallel and the transversal line will be the red one. So I could say that angle D is congruent to angle 2 by the same reason. Now I can go ahead and say, well, angle 1 and angle D right? Angle 1 plus angle D. When you add them to each other, notice that they are on the same side. So they're add up to 180, and the reason is same side interior angles. Add up to 180. Okay. Okay, so notice again, like I mentioned before, sometimes you may have less steps than other students. So actually what I noticed was that angle D and angle 2, you probably don't even need to mention that. So all I needed to have was angle B, angle 1, and angle D. In step 3, in statement 3, you said angle 1 and angle D are equals to 180. So these two have to add up to 180. The reason is same side interior angles add up to 180. Now in this case, we are going to do for step 4, B and D is just going to substitute. Notice that angle 1 could also be written as angle B. So that's what we did right here. Angle B plus angle D is equals to 180, and the reason is substitution. And that's it.